most recent advances happening in science at this stage. So the first thing I want to let you know that so far I have recruited 82 pediatric subspecialists to this institution. And I'm still working on continually to increase the number of pediatric subspecialists, because the more we bring in subspecialists from various places in the country, the stronger we are and we can serve you much better. So my task for the next year is to really make it to 100 basically pediatric subspecialists which I have recruited. So I'll tell you about specifically our pediatric bone marrow transplant first, and how I built this program, because when I arrived to this town from Vanderbilt University, where I was the vice chairman of pediatrics and director of their gastroenterology program, I had one individual here by the name of John Hutton, one pediatric hematologist for the entire southern Arizona. Imagine, 1 million people, you have only one individual. So I met with John, I said, John, how are you doing it by yourself? There's no way. We're gonna have to recruit more people. You can't just leave it like this. He said, well, I'm trying, but I can't. I said, okay, well, let's really try to increase the size of that unit and make it a significantly unit which is dedicated for finding cure for pediatric cancer, and then finding research and building that program. So the first thing I did is I recruited a guy by the name of Manny Katsans, who heads our unit. He's been with me 20 years. Well, he's from Minnesota. So what did I do? I never recruit anyone here during the summertime. Summertime, no. Done. So basically, I brought him here in January from Minnesota. So of course it was snowing in Minnesota. It was so bad. So I take him to a bagel place outside, and we sat outside to have coffee and bagel. And he said, man, this is incredible. Could you sign here? So nonetheless, I was able to recruit Manny, because Minnesota has a great program in bone marrow transplant. So I wanted to build that big pediatric bone marrow transplant. But then after Manny, of course, we have recruited so many other individuals from MD Anderson in Texas, and we recruited people from Baylor Medical School, for example, a number of people from there, so University of Iowa. So we recruited a lot of people to that unit now. So the pediatric hematology oncology unit is quite large, and they do both basic science research as well as clinical translation research. I can assure you that basically our program here utilizes what we call using the immune system, something called immunotherapy, to really enhance basically the care for pediatric cancer. So this is the old dogma that you have a cancer cell and you target either chemotherapy or antibodies against the cancer cell and try to kill it. Well, the new paradigm in pediatric cancer nowadays is really to train the cells in the body. It's called T cells. T cells for thymus, T lymphocytes, and train those T cells to attack the cancer rather than directly attack cancer, allow the body to cancer. The problem is cancer cells, as you know, they are terrible cells. So they cover themselves by certain antibodies to allow the T cell to recognize them. So nowadays, basically, we're trying at least to break that recognition, allow the T cell to recognize the cancer cell as a foreign cell and kill it. Okay? So that's the concept of immunotherapy which is going on here. So Manny Katsans has been a leading, basically, investigator in this area to try to help our patient using immunotherapy along with basically doing bone marrow transplant. That's an incredible, really, program for the entire southern Arizona. We are seeing patients from New Mexico, we're seeing patients, they come to us from Nevada, from Las Vegas. They come here because of our strength, because our success rate has been exceedingly high, and therefore we are attracting patients to come from various places around the country. So now I'm going to tell you about what's happening in science. Just two highlights I want to make for you basically in science. The first thing is this something called genomic medicine. Remember, we as human beings, we have 23,000 genes, and these genes, they control everything. The genes make something called RNA, and then RNA make protein, and the protein function, and that's how you function. Okay, so the question is, how are we gonna know, for example, whether an individual is gonna respond to a chemotherapy we're gonna give that individual or not, okay? Well, in the past, we used to give it to them and see what happens, okay? Nowadays, that's not gonna happen. So we formed a genomic consortium with a number of other children's hospitals around the country, 5 other children's hospitals, including Rady in San Diego, Denver Children's Hospital, LA Children's Hospital, Minnesota Children's Hospital, and Sanford Health. Well, don't ask me why we're getting Sanford Health from South Dakota. Well, the reason why, because these guys, they have money. And we're gonna try to convince this guy, Dennis Sanford, to give us money to fund this, okay? So I went to basically South Dakota, met with this guy, Dennis Sanford, and we talked with him about funding this program. So he connected us with an individual by the name of, he's in San Diego, and this individual was the first scientist to sequence the first human genome in 2003. So that's, imagine, 2003, it cost $100 million to sequence one human being. 1,200 patients, people, they were sequenced, and then we call them the reference genome. So that's reference genome. Now, when I sequence, for example, one of you and sequence your genome, we look at the reference genome and say, okay, well, you know, you have a different mutation, for example, in that. Okay. So $100 million in 2003. So we went to San Diego. This is an institution called the Human Longevity Institute. And we basically discussed with them doing whole genome sequencing for $1,000. Imagine, from $100 million, today, it's $1,000. So this is gonna be the future of medicine. Future of medicine is gonna be in personalized medicine, and we are way ahead of everyone else in the country in doing this personalized medicine. So we're gonna basically sequence the whole human genome for $1,000. And if I know where the mutation is, that's easy. You can do it for $100. You can amplify basically where the mutation is, and then you can figure it out with $100. So that's simple. We can do it in our labs at the Steele Center. But the future is going to be based on genome. However, if I tell you that the genes are the bullet, the trigger for the bullet is the environmental factors, okay? So I want to assure you, each one of you, that biology is not your destiny. Even if I tell you you are inheriting a gene mutation, you can actually change your biology because you are not destined, for example, to have a major problem if you have that mutation. We can change it by changing basically the trigger. So now we are concentrating on the environment, okay? Because we truly believe that the environment plays a major role. The diet you eat, whether you exercise or not, whether you basically do things for others, like kids of Steele. That basically, they get basically a satisfaction by doing this, and we think that that's part of the environmental factors if you do good things for other people. Okay. So the second area which I'm going to tell you about is this autoimmune diseases. So we believe that there is more than 100 autoimmune diseases in this country. 25 million people affected with autoimmune diseases in the United States alone. There are 1 million children who have autoimmune diseases. But we don't know why would someone get type 1 diabetes while the other sibling doesn't get type 1 diabetes. So we need to figure out the trigger. And that's what we are concentrating on at this day. So I just received, basically in September, I just received $1.7 million from the National Institute of Health to really try to figure this thing out for the next 5 years. And then last Friday, I heard that I got another $1.9 million to really continue number of other studies on trying to figure out these environmental factors and cancer. Okay. So the thing is, how does Kids of Steele help us solve some of these problems? Well, look, they raise money, but the money they raise to help patient care, but it also gives us the drive to generate some preliminary data and then go to the National Institute of Health and get millions of dollars to do so. So that's how it works. It's so exciting when the National Institute of Health, 25 scientists sitting there, they think our program is #1 in the country. And they give us the money. Trust me, the National Institute of Health, they don't give money for nothing. It is so difficult to get money nowadays. Every 100 basically proposals come to them, maybe 7, maybe 8 get funding, okay? And we are considered one of the tops in the country. So autoimmune diseases is something we're gonna concentrate on. But if you come Tuesday to my lecture in La Paloma, I'm gonna be talking about the microbiome of the gut and how we can manipulate this gut microbiome to really prevent these environmental factors from getting into you, okay? So look, the future, I believe in our hand. We can change our biology, we can change whatever we inherit from our parents, we can change it, and we can be healthy for a long period of time. And that's what science is providing us. Science is so beautiful because you make discoveries which help kids. In my life, I want to continue to see smiles on the kids' faces. I don't want to see any parents come to me and crying. I really don't want to see that. It aches my heart to see that. I want to make sure every kid who has a problem, I need, with my people, I need to make sure that I can solve that problem. This is how I'm dedicating my life, with 50 years being a doctor now, and God give me health, I'm gonna continue to do whatever it takes to really improve the lives of children. Through science though. We need to use science to improve the lives of kids. I don't just see patients alone, and without doing the science to figure out their problems, we're not doing any improvement in their lives, right? We don't know, you know. So if we didn't discover vaccines, for example, for polio, we continue to see polio until today. But we don't see polio anymore. We don't see smallpox anymore. We don't see many of these diseases, you know. And we can improve the lives of kids. But we need people like Kids of Steele. Because their dedication to me, that to me is the drive. It's not really the money. It's the drive when I see parents trying to figure out to help other kids. That gives me the drive to continue to work every day. So I want to thank you for being here today and for supporting Kids of Steele. They are wonderful people. And I hope next year I'll give you another talk with what we have done basically during the last year. So part of the research we are doing, it will have fruits in the next year. So thank you so much for being here.